Bismillahirrahmanirrahim. Assalamu alaikum, dear students. The textbooks recommended for HSSC Part 2 are: number 1 is Introduction to Statistics Part 2, written by Dr. M. Afzal Beg and Mirajuddin Mirza. The second recommended book is Basic Statistics Part 2, written by Ghulam Hussain Kiani and Muhammad Salim Akhtar. The course contents of this book are comprised of 10 chapters. Chapter number 1 is Rules of Counting. Chapter 2, Probability. Chapter number 3, Random Variables. Chapter number 4, Binomial Distribution and Hypergeometric Distribution. Chapter number 5, Normal Distribution. Chapter 6, Sampling Distribution. Chapter 7, Estimation. Chapter number 8, Testing of Hypothesis. Chapter 9, Association of Attributes. And Chapter 10, Orientation to the Computers. Practical notebook will consist of the following topics. Number 1, Probability, Discrete and Continuous Probability Distribution. Number 2, Binomial, Hypergeometric and Normal Distribution. Number 3, Statistical Inference, Association. Number 4, Orientation to the Computers. Chapter number 1, Rules of Counting. Learning objectives of this chapter are: after studying this chapter, the students will be able to describe fundamental principles of counting, to explain the meaning of permutation, to interpret the number of permutations of n different objects taken r at a time. The students will be able to explain the meaning of combination, to interpret the number of combinations of n different objects taken r at a time. Counting rules. Counting rules help us to know about the number of all possible results of an experiment without actually listing them. The solutions of many problems in probability may require some knowledge of rules of counting, and many times a person must know the number of all possible outcomes for a sequence of events. To determine this number, these three rules can be used. Number 1 is Fundamental Counting Rule. Number 2, Permutation Rule. And number 3 is Combination Rule. Fundamental Counting Principle. Fundamental counting principle is used to find the number of ways 2 or more events can occur in a sequence. For a sequence of 2 events, if one event can occur in m ways and another event can occur in n ways, the number of ways the 2 independent events can occur in a sequence is m times n. For example, if a woman has 3 skirts and 4 sweaters, how many outfits are possible? To answer this question, as we know that there are 3 skirts and 4 sweaters, so we multiply 3 by 4. 3 times 4 is equal to 12. There are 12 possible outfits for a woman. The fundamental counting rule can be extended for any number of events occurring in a sequence. In extended form, the fundamental counting rule states that in a sequence of n events, if first event has k1 possibilities, the second event has k2 possibilities, similarly the third event has k3 possibilities, and so forth, the total number of possibilities of the sequence will be k1 multiplied by k2 multiplied by k3, so on till kn, the product of all possibilities. An example of fundamental counting principle in extended form is: let's suppose you are purchasing a new car. The possible manufacturers, car sizes and colors are listed. The three manufacturers are Ford, GM and Honda. The two car sizes available are compact size and mid size, and four available colors are white, red, black and green. Now the question is, how many different ways can you select one manufacturer, one car size and one color? To answer this question, we know that three choices are for manufacturer, two choices for car size and four colors are available. So we multiply 3 by 2, 3 2s are 6, 6 4s are 24. There are 24 possible ways in which you can buy a car. Using a fundamental counting principle, with three choices of manufacturers, two car sizes and four colors, we multiply 3, 2 and 4, which is equal to 24 ways. Using a tree diagram, you can see there are three choices for manufacturers, Ford, GM and Honda. For each manufacturer, two car sizes are available, compact size and mid size. And for each car size, there are four colors which are available, white, red, black and green. So with Ford compact size, you can select any of the four colors, and with manufacturer Ford car size mid size, four colors are available, 4 plus 4 8, 4 8, and with GM two car sizes 4 and 4 8, and with Honda manufacturer two car sizes 4 and 4 8. 8 plus 8 plus 8 equal to 24 possible outcomes. Factorials. A factorial is a counting method that uses consecutive whole numbers as factors. Both rule of combination and rule of permutation use factorials for counting possible outcomes. The factorial of a number is product of all the whole numbers from the number down to 1, and factorial of 0 is defined to be 1. 0 factorial is equal to 1. To answer a question like how many ways can 5 people be seated on a bench, we will use the factorial rule. 5 people that can be seated on a bench is 5 factorial. 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 120. So 5 people can be seated on a bench in 120 possible ways. An example evaluating expressions containing factorials. Evaluate each expression. A part 9 factorial. 9 factorial is equal to the product of first 9 natural numbers. 9 factorial equal to 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equal to 362880. The product of first 9 natural numbers is 9 factorial and is equal to 362880. In B part, 8 factorial over 6 factorial. In the numerator, 8 factorial is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. In denominator, 6 factorial is 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Now simplifying this expression, we are left with 8 multiplied by 7, which is equal to 56. In the C part, 10 factorial over 9 minus 2 factorial. 10 factorial is once again product of first 10 natural numbers. And in the denominator, 9 minus 2 factorial is equal to 7 factorial. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. Simplifying this expression, we are left with 10 into 9 into 8, which is equal to 720. Evaluate each expression yourself. You can use calculators to solve these expressions. 9 factorial is equal to 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Similarly, in the second part, 9 factorial over 5 factorial. And in the third part, there are 8 hot air balloons in a race. In how many possible orders can all 8 hot air balloons finish the race? You should solve these expressions yourself and match the solution. 9 factorial is equal to 362880. 9 factorial over 5 factorial is equal to 3024. And 8 hot air balloons in a race. So there are 8 factorial. Possible ways are 8 factorial, which is equal to 40320. The second rule is rule of permutations. A permutation is an ordered arrangement of all objects taken from n distinct objects in a particular order. The formula for number of permutations is NPR equal to n factorial over n minus r factorial. Some important points about permutations. Number 1 is a permutation is an arrangement of all or part of a set of objects. Number 2, number of permutations of n distinct objects taking all at a time is n factorial. And number 3, number of permutations of n distinct objects taking r at a time is npr, which is equal to n factorial over n minus r factorial. Number 4, number of permutations of n objects arranged in a circle is n minus 1 factorial, which are also known as circular permutations. Number 5, the number of permutations of n objects when n1 objects are identical, n2 objects are identical, and so on, and k objects are identical, then formula for permutation is n factorial over n1 factorial into n2 factorial into n3 factorial, so on, and k factorial. And where n is equal to n1 plus n2 plus n3 plus up till so on plus nk. Circular permutations. When the items are arranged in a circular format, then to find the number of arrangements, divide n factorial by n. N factorial over n is equal to, n factorial can be written as n into n minus 1 into n minus 2 into n minus 3 into n minus 4 and so on down to 1. And we can simplify n factorial as, in simplified form, we can write it n into n minus 1 factorial. Rest of the terms are included in this factorial. So n factorial divided by n is equal to n into n minus 1 factorial over n. Simplifying this expression, we are left with n minus 1 factorial. Example of circular permutations. 6 students are sitting around a table in a cafeteria. How many different seating arrangements are there? Since there are 6 students, so n equal to 6. We divide 6 factorial by 6, which is equal to 5 factorial. And 5 factorial is the product of first 5 natural numbers, which is equal to 120. So there are 120 seating arrangements for the 6 students in a circular format. Rule of permutation. An example. A permutation is